In this tutorial video we will be learning about linear regression. We will be doing this in Google Colab. Like we did in previous video, we will start with installation of BlueCat. We can do it by using this code !pip install BlueCat. Type the code that was shown earlier in Google Colab. Then click on play button and BlueCat will be installed. Linear regression. Here we describe linear regression using annealing. Loss function for linear regression. Let x be the data vector, with n variables, and y be the target value you want to predict for it. Assuming that y is predictable by the weighted sum of each variable, we can consider the following weight vector w. Next, suppose we have a training data set X, M times N matrix, consisting of M data and target data Y, M-dimensional vector. The goal of linear regression is to find a single weight vector W that predicts the corresponding Y for all the data X in X. This becomes a function minimization problem as follows. By transforming EW, let W equals P hat W to encode the weights W into qubit measurement results. Hat W is a vector consisting of qubit measurement results, 0, 1. We also omit y to the power ty, which does not affect minimization. Then it can be reduced to a general cubo problem, which can be solved by annealing. It is worth noting that the size of the cubo matrix does not depend on the number of data contained in the dataset. The size is the number of variables in the data times the number of qubits used to encode the weight values. Let's implement this using BlueCat. First import pandas, numpy and matplotlib.pyplot. The first step is to create a dataset. This time, we will set the weights we estimate in advance. Generate the dataset X randomly, and calculate the weighted and noise added value to be the target data Y. Let's do a classical linear regression using scikit-learn. Although there is a slight deviation due to the addition of noise to the target data Y, the predetermined weights can be estimated with good accuracy. Annealing encodes each value of the weights W into a number of qubits. What value to encode can be set arbitrarily with the transformation matrix P in the above formula. Here we simply encode one weight parameter into 2 qubits and predict it from 4 values of 0, 0.25, 0.5, 0.75. The number of qubits to use as number of qubits used for encoding times number of variables equals 2 times 3 equals 6. Now convert the result of annealing into the value of the weight parameter and compare it with the value that was originally set. It was correctly predicted. Here, the encoding is determined according to the value of the originally set weight W, so it can be estimated exactly. In reality, there is an error due to the encoding. It is necessary to prepare more qubits to reduce the encoding error. That's all for today. Thank you.